So, good morning. Today we are going to discuss the first chapter, that is fuels and combustion. So, fuels and combustion. So, first of all, let us learn what is meant by the word fuel. So, fuel ante enti? Can anybody tell me? What is meant by fuel? Mr. Nikhil. Fuel ante enti? Shekhar? నువ్వు ఇక్కడ కూర్చోకు, అక్కడ కూర్చో. సరే ఇక్కడికి వచ్చి వైర్ చూసుకో, అక్కడ కూర్చో. ఏంటి ఏమైందిరా? Type of liquid. So, when you are burning a stove with wood, so what is the fuel there? Wood. Is it a liquid? No. Then, so fuel is a substance which can give heat on burning. Is it right or not? Question. So fuel is a substance which can give heat upon burning. So there is a standard definition for fuel. It is a substance that can be burnt. So fuel is a substance that can be burnt in presence of oxygen. So oxygen is required for burning. We know all about that fact. So in presence of oxygen. So fuel is a substance which can be burnt in presence of oxygen. What is the purpose of burning? To produce heat. So finally the purpose is to release heat energy. To release heat energy. So fuel is a substance which can be burnt. So for burning it requires oxygen. So in presence of oxygen we are burning. Okay. So what is our ultimate aim? Our ultimate aim is to release the heat energy. So and this heat energy can be used for any purpose. Okay. So fuel is a chemical substance that you have to observe. So fuel is a chemical substance. That means it consists of certain chemicals with some heating value. It consists of some chemicals with some heating value. Now can anybody tell me what are the chemicals available in any fuel? Standard chemicals. Not dioxide, carbon, hydrogen. Most of the fuels are having carbon and hydrogen, and these two are having certain amount of heating values. Okay, and the fuels which are having carbon and hydrogen are called as hydrocarbons. Hydrocarbons. So most of the fuels are having hydrocarbons. So that's why they are called as hydrocarbon fuels. Of course, some fuels may have small quantities of sulfur also. But most of the heating elements are carbon and hydrogen, and in between these two also carbon is having more amount of heating value, right? So that is about hydrocarbon fuels, and these fuels can be of liquid form or solid form or gaseous form. So in liquid form you can find petrol, diesel, kerosene, everything, and in solid form you can find coal, wood. Okay, all these are solid forms. Similarly, in gaseous form, you can observe that gases like LPG gas, which we use at our home for cooking. Similarly, compressed natural gas, that is CNG, which we use in automobiles. So these are the various forms of fuels. Right. Now, what are the desired characteristics of fuel? So in order to use the fuel for combustion process, what are the essential qualities of a fuel? What are the essential characteristics that a fuel should possess? That we have to learn first. So now the topic is characteristics of fuel. What are the characteristics required? First of all, any fuel must have the easy ignition capability. That means you have to ignite the fuel for the process of combustion. Ignite means veliginchadam. So it must be easily ignitable. It must be easily ignitable. So let us take two fuels, say coal and gas. Which is easily ignitable? Gas is easily ignitable. So in our gas stove, simply with the click of lighter, the stove burns. But whereas if you take coal, it is somewhat difficult. It is not easy to ignite the combustion process by using coal. So any fuel should have easily ignitable property. So that is the first property, and then it should have high heating value. High heating value. Simply saying it should have high calorific value. So what does it mean? No. See, if you take 1 kg of fuel A and fuel B also you have taken 1 kg of fuel. So there are two fuels A and B. So on burning 1 kg of fuel, so it is giving say 40,000 kilojoules of heat, and this is giving 60,000 kilojoules of heat. So which is having more heating value? B. Because with 1 kg of fuel you are getting 60,000 kilojoules of heat, but here with 1 kg of fuel you are getting only 40,000 kilojoules of heat. So in order to get 60,000 here, in order to get 60,000 kilojoules of heat by using fuel A, you have to use 1.5 kgs of fuel. If you want 60,000 kilojoules of heat, and if you want to use fuel A, you have to use 1.5 kgs of heat. But by using fuel B, you can use only 1 kg of fuel because its heating value is more. That means if the heating value of a fuel is high, then you can get more heat with small amounts of fuel. With less quantity of fuel, you can get more amount of heat. So that is the advantage of having high heating value. And the next one is, for any combustion or burning process, smoke is emitted, which is inevitable. Smoke is emitted. So as far as possible, the smoke must be less. The smoke must be less. If you burn a wood, it will give a lot of smoke. But if you burn a gas, it will give very little quantities of smoke. Do you find any smoke in your gas stoves? No, it will not give any smoke. But if you use a wooden stove, kattil poi antaru kada, so there you can find huge amount of smoke. Or if you use coal, if you burn the coal, you will find huge amounts of smoke. Okay. Even if you burn petrol or diesel, there also you will get smoke. But as far as possible, the smoke must be minimum. Why? What is the reason? What happens if the smoke is more? No. It causes pollution. If smoke is high, it causes pollution. So that's why it should have low smoke emission. Okay. So, and the next one is easily controllable combustion characteristics. So I should have easily controllable combustion characteristics. Simply saying, you have to control the combustion if necessary. For example, you are boiling some milk on a stove. So there also the fuel is burning and combustion is being taken place, and then the milk is boiling. So what happens if the milk rises? What will you do? You will convert the flame into smaller flame. You will reduce the flame. That means you are controlling the flame. That means you are controlling the combustion process. Based on your requirement, sim lo kani high lo kani pettaru kada. So based on the requirement, you can adjust the flame. So that is easily controllable combustion. But if you take the combustion with wood, వంట చెరుకుతోటి కలపతో మీరు చేస్తున్నారు అనుకోండి, ఈజ్ ఇట్ ఈజీలీ కంట్రోలబుల్? No. What will you do? If you want more fire, more heat, then you have to put more quantities of wood into the furnace, and it will take some time to produce the heat. It will not give us heat immediately. Similarly, if you want to reduce the combustion, you have to take out the burning fuel out of the stove. So it is not easily controllable. But as far as possible, any fuel which you use must be easily controllable. And finally, it should have low impurities. It should have low content of impurities. See, what happens if you burn a wood or coal? After burning, it will leave us with some quantities of ash. Is it right or not? బూడిద మిగులుతుందా? సో బూడిద ఉంది అంటే దాని అర్థం ఏంటి? Every fuel will have a certain amount of ash or impurities, so which has no heating value. Which has no heating value. Simply it goes off as a waste. So which is not desirable. So as far as possible, it should have any fuel should have low quantities of impurities. Impurities ఎంత తక్కువ ఉంటే మనకు అంత మంచిది. ఎందుకంటే ఇంప్యూరిటీస్ వల్ల మనకి ఎటువంటి హీటింగ్ వాల్యూ రాదు. ఎటువంటి హీటింగ్ వాల్యూ రాదు కాబట్టి. ఓకే, సో ఆల్ దీస్ ఆర్ ద క్యారెక్టరిస్టిక్స్ ఆఫ్ ఫ్యూయల్. సో ఇఫ్ ఎ ఫ్యూయల్ possesses all the characteristics, then we will say that is a good fuel and you can use that. Okay, just note it down. Next, classification of fuels. So how do you classify the fuels? So according to the state or phase in which they exist. First one is according to the state or phase. So these fuels can be classified into three categories. The first one is solid fuels. Second one is liquid fuels. And the third one is gaseous fuels. So what are the examples for solid fuels? Coal and wood. All these are the examples for solid fuel. And liquid fuels, our petrol, diesel, etc., kerosene. And for gaseous fuels, our LPG, CNG, etc. So all these are the examples for the different categories of fuels according to the state. There is another classification, that is according to the nature of production. According to the nature or origin, అంటే ఎక్కడి నుంచి వచ్చాయి ఫ్యూయల్స్ అనేవి. సో the first one is natural fuels. Natural fuels. And the second one is artificial fuels. Natural fuels or artificial fuels. So natural fuel means these are available in nature. You are not making these fuels. You are not producing these fuels. They are readily available in the nature. So they are called as natural fuel. Say for example, petroleum. Okay, petroleum, wood. All these are natural fuels. Generally, fossil fuels, that means the fuels which are available under the ground, under the earth, are called as fossil fuels. So fossil fuels will come under the category of natural fuels. In case of artificial fuels, you are producing these fuels from the natural fuels. You are making the production of the artificial fuels by using the natural fuels. Say for example, by using petroleum, you are making petrol, diesel, kerosene, etc. Similarly, by using wood, you are making coal or sometimes coke. All these are being produced. So these are called as artificial fuels. Okay, right. You just make a note of all these things. Right. Now we shall discuss certain terms related to the combustion. Certain terms. So the first one is combustion. Can anybody tell me what is meant by the word combustion? So we have already seen in IC engines that combustion takes place inside the cylinder. So what is meant by combustion? Burning of fuel. Good. Inka? Yes, it is a chemical reaction. It is a chemical reaction. So basically this combustion can be defined as it is a chemical reaction. So what happens in this chemical reaction? So in this chemical reaction, the fuel which we are using is oxidized. That means the fuel or the fuel constituents like carbon, hydrogen, they are oxidized. That means they are reacting with the oxygen. The fuel constituents are reacting with the oxygen. So finally what is happening? The heat is released. So that huge quantities of or huge amounts of heat is being produced. So basically the combustion is a chemical reaction in which the fuel is oxidized and produces huge amounts of heat. Okay, so that is combustion. So what is the oxidizer which we use in combustion process? Tell me. What is the oxidizer we use? Oxidizer means which supplies oxygen. It is a substance which supplies oxygen. So which substance supplies oxygen in the combustion process? Air. So you are supplying air to the combustion. Without air you cannot perform combustion process. So you are supplying air. That means you are supplying oxygen with the help of that air. So atmospheric air consists of nitrogen, oxygen and other elements. So here that oxygen is used for the combustion process. So air is the oxidant, or it is the oxidant which we supply for the process of combustion, for normal combustion. Of course, under special circumstances, oxygen is directly supplied to the combustion process. Say liquid oxygen. For example, if you go to space, there, for example, rockets are being sent to the space. So there is no air. That's why they will carry its own oxygen in tanks. So that oxygen is used for the combustion. Okay? But in the atmospheric conditions, just air is sufficient for the combustion. Right. Now, this combustion may be complete combustion or incomplete combustion. So it may be complete combustion or incomplete combustion. What do you mean by complete combustion? Kranti, complete combustion ante enti? హీట్ ఎనర్జీ అనేది సరిగా అంటే హైగా ఉండాలి. నో, సి combustion means what are the constituents in the fuel? Mostly carbon and hydrogen. So they are having certain amount of heating values. So if all the constituents of the fuel are completely burnt, if all the constituents of the fuel are completely burnt, then we will say that the combustion is complete. But if certain traces of or certain quantities of carbon or hydrogen are left over after combustion, then we will say that it is incomplete combustion. Did you get my point? See, every fuel will have certain quantities of oxygen and carbon and hydrogen. So if all the carbon in the fuel or if all the hydrogen in the fuel is completely burnt, that means complete heat energy is released. Then in such cases we will say that is a complete combustion. If certain quantity of, say for example 80% of the carbon is burned but remaining 20% of the carbon is left, that means that 20% will leave as waste. So such combustion is known as incomplete combustion. Complete combustion jaradu anta konta heat waste అయిపోయింది. Okay, so that is known as incomplete combustion. Well, now what are the conditions for complete combustion? So which is desirable, complete combustion or incomplete combustion? Complete combustion is desirable because it will gives us more amount of heat than incomplete combustion. So what are the requirements for complete combustion? Tell me. ఎప్పుడు కంప్లీట్ కంబషన్ జరుగుతుంది? ఎప్పుడు జరగదా? జరుగుతుంది. ఎప్పుడు జరుగుతుంది? మణిదీప్, నో, మంచి క్వాలిటీ ఉన్న ఫ్యూయల్, ఒక మంచి క్వాలిటీ ఉన్న ఫ్యూయలే ఇచ్చాం కానీ కంబషన్ కంప్లీట్గా జరగట్లేదు. సో if you can supply sufficient quantity of oxygen, then the combustion can be complete. So కొంత కంబషన్ జరగకుండా ఉండిపోతుందని చెప్పాం. వాట్ ఈస్ ద రీజన్? సో 80% కార్బన్ కంబషన్ జరిగిపోయింది and remaining 20% has left over. What is the reason for it? Because it could not find sufficient amount of oxygen for burning the 20%. That means there is a scarcity of oxygen. So if you can supply sufficient amount of oxygen, sufficient amount in the sense అది కంబషన్ జరగడానికి ఎంత అవసరమైతే అంత, if you can supply sufficient amount of oxygen to the combustion process, then the combustion will be a complete combustion. Oxygen in the sense air. So if you can supply sufficient amount of air, then you can get complete combustion. Not only that one, and also you must the temperature of the fuel must be sufficient to ignite the combustion. So every fuel will have certain ignition temperature. So before combustion the temperature must be reached to that value. So that's what we have discussed in combustion of CA engines. So in the CA engines the air is compressed to a temperature at which the diesel which is sprayed onto the air can ignite. Okay, so there must be, the temperature must be at least equal to the ignition temperature. That means ignition temperature reach అవ్వాలి కనీసం. ignition temperature కంటే ఎక్కువ ఉంటే మంచిదే, బర్నింగ్ ఇంకా బాగా అవుతుంది. అట్లీస్ట్ ignition temperature రీచ్ అవ్వాలి. ignition temperature కన్నా తక్కువ ఉందనుకో టెంపరేచర్, మీరు సఫిషియెంట్ ఎయిర్ సప్లై చేసినా సరే కంబషన్ జరగదు. ఎందుకు అంటే ద ఫ్యూయల్ హ్యాస్ నాట్ రీచ్ ఇట్స్ ignition temperature. ఆ టెంపరేచర్ దగ్గరే అది ఇగ్నైట్ అయ్యి బర్న్ అవుతుంది. ఓకే, సో ఇట్ షుడ్ హ్యావ్ రీచ్డ్ ignition ద మినిమమ్ ఆఫ్ ignition temperature వాల్యూస్. సో ఆ రెండు కండిషన్స్ ఉంటేనే మనకి కంబషన్ అనేది కంప్లీట్గా జరుగుతుంది. ఓకే, రైట్. అండ్ ద నెక్స్ట్ వన్, the next term related to the combustion is reactants and products. Reactants and products. What does it mean? What is a reactant and what is a product of combustion? The component that exists before the combustion are called as reactants. So they exist before combustion. So that is called as reactant. And the component that exists after the combustion is called as reactants. So for example, so before the combustion, the C, carbon present in the fuel, will mix with oxygen and gives us carbon dioxide, CO2. Is it right or not? So before the combustion, the fuel will have carbon or hydrogen. Okay, so here carbon or hydrogen is the reactant. And after combustion, what is happening? Is it continuing?
Stop it. Continue.
Yeah. So after combustion, what is formed? CO2 is formed. So this is the product of combustion. So before combustion, reactant exists. After combustion, products of combustion exists. So that is about reactants and products. Next one, stoichiometric air. So we have seen this term in air fuel ratios, stoichiometric fuel air ratio. Similarly, stoichiometric air, what does it mean? stoichiometric, stoichiometric air. It is also called as theoretical air required for the combustion. So stoichiometric air. See, for combustion process, we know that certain amount of air is required. So if sufficient amount of air is supplied, then the combustion will be complete. So that we have learnt already. So what is the sufficient amount of air? The air which is just sufficient to make the combustion complete, or the air which is just sufficient to completely oxidize the elements. So carbon and hydrogen are there. So the amount of air that is sufficient to completely convert the carbon into carbon dioxide, or to completely convert the hydrogen into H2O. So that is known as stoichiometric air or theoretical air. So if the air supplied is less than stoichiometric air, then the combustion will be incomplete. If the air supplied is less than stoichiometric air, then the combustion will be incomplete. ఎందుకంటే this is the minimum amount of air required. ఇంత ఎయిర్ ఉంటేనే కంబషన్ కంప్లీట్గా జరుగుతుంది. ఇంతకన్నా తక్కువ ఉంటే కంబషన్ కంప్లీట్గా జరగదు. అంటే ఎంతో కొంత కార్బన్ కానీ హైడ్రోజన్ కానీ ఉండిపోతాయి ఫైనల్గా. Do you get my point? So that is stoichiometric air. Then what is excess air? Excess air means the amount of air supplied in excess of the stoichiometric air. See, for example, మనకు 1 kg ఫ్యూయల్ బర్న్ అవ్వాలి అంటే 1 kg ఫ్యూయల్ బర్న్ కంప్లీట్గా బర్న్ అవ్వాలి అంటే సే 1/2 kg ఆఫ్ ఎయిర్ అనుకుందాం, లేదా 1.5 kgs ఆఫ్ ఎయిర్ సప్లై చేయాలి. ఈ ఫ్యూయల్కి 1.5 kg ఆఫ్ ఎయిర్ సప్లై చేస్తే ఇది కంప్లీట్గా బర్న్ అవుతుంది. Then this 1.5 kg will be the stoichiometric air. 1.5 kg కాకుండా మనం 1 kg సప్లై చేస్తాం అనుకోండి, కంప్లీట్గా బర్న్ అవుతుందా? Then it is incomplete combustion. అలా కాకుండా if you supply 2 kgs, ఇప్పుడు బర్న్ అవుతుందా? అవుతుంది. ఎందుకంటే మినిమం 1.5 kg ఉంటే చాలు, కానీ 2 kg సప్లై చేసినా బర్న్ అవుతుంది. సో మీరు ఇక్కడ ఎంత ఎక్స్ట్రా సప్లై చేశారు? half kg. So this half kg is called as excess air supply. So that half kg is the excess air that is supplied. అంటే మనకి ఎంత కావాలో అంతకంటే ఎంత ఎక్కువ సప్లై చేసామనేది. So that is called as excess air. So is it necessary to supply excess air for any combustion process? Sometimes it may be necessary depending on the conditions. Sometimes it may be necessary to supply excess air to the combustion process based on the combustion conditions. Okay? So అటువంటి సిచ్యువేషన్లో స్టాకియోమెట్రిక్ ఎయిర్ ఒకటే సప్లై చేసి సరిపోదు, కొంత ఎక్స్ట్రా కూడా సప్లై చేయాల్సి ఉంటుంది. యు గెట్ మై పాయింట్? రైట్. నౌ now let us move to the analysis of coal. Analysis of fuel. So there are two types of analysis: proximate analysis and ultimate analysis. So we shall look into it briefly and we shall discuss about these things later in detail. So fuel analysis. So fuel analysis determines, the first one is proximate analysis and ultimate analysis. So what is this proximate analysis and ultimate analysis? So by conducting the proximate analysis, by analyzing in this way, you can get the percentage mass of the fuel constituent. So it will give us percentage mass of fuel constituents. So what are the fuel constituents? Like carbon, hydrogen, sulfur and some volatile matter, volatile components. So these are the constituents of fuel. Fuel లో ఉండేవి ఇవి. మీరు ఏదైనా ఫ్యూయల్ తీసుకుంటే దాని లోపల ఉండేవి ఇవే ఉంటాయి. These are the compounds or substances. So in proximate analysis, you are calculating the percentage of mass of each and every compound. Say for example, if you have taken 1 kg of fuel, any fuel. So in this 1 kg, it consists of say 70% of carbon and 20% of hydrogen, say 3% of sulfur, and the remaining is volatile compounds. So what does it mean? 70% of carbon is there by mass. That means you have taken 1 kg of fuel or you have taken 100 kgs of fuel. So out of 100 kgs of fuel, 70% is carbon. That means 70 kgs of carbon is there in that fuel and 20 kgs of hydrogen is there and 3 kgs of sulfur is there, and the remaining, how much is that? 7%. And 7 kgs of volatile compounds are there. So by using this proximate analysis, you are going to calculate the percentage of mass of fuel constituents like carbon, hydrogen, everything. So that is about the proximate analysis, which is necessary to analyze the properties of fuel. And the next one is ultimate analysis. So this ultimate analysis also gives us the composition of fuels, just like this one. It also gives us the composition of fuel. The composition means what are the constituents of fuel, like what is the quantity of carbon, what is the quantity of hydrogen, what is the quantity of oxygen. Some fuels may have oxygen also, and that oxygen can be used as the combustion, for the combustion process. Okay, and sulfur may also be there. So that is about proximate and ultimate analysis. Okay, we shall discuss about these two things in detail later. For the time being, just note it down. Right. Now the next topic is the quantity of air required for the process of combustion. ఎంత quantity of air అనేది మనకు కావాలి. See, for example, carbon ఉంది. Carbon, if you want to burn carbon, how much quantity of air is required? Say, if you want to burn 1 kg of carbon, how much quantity of required? Similarly, see, a fuel, 1 kg. So, you have taken 1 kg of fuel. So, in this 1 kg of fuel, it may have carbon, hydrogen, all these constituents are there. Okay. So, if you burn the 1 kg of fuel, all the components will be burnt. Am I right or not? Whatever be the constituent of the fuel, everything will be burnt. So, in order to burn all the constituents of the fuel completely, how much quantity of air is required? So, that is our question. See, this 1 kg of fuel మనం burn చేయాలంటే ఎన్ని కేజీల ఎయిర్ కావాలి? So, that is our question. So, in order to find out this, you must understand what are the constituents of the fuel first. So, it may have, say, carbon, hydrogen, sulfur, etc., etc. So, if you can find out what is the quantity of air required to burn carbon completely, so it will have some value. And what is the quantity of air required to burn hydrogen completely, so it will have some value. What is the quantity of air required to burn sulfur completely, so it will have some value. And if you add all the quantities of air, then it will give us the total quantity of air required to burn the complete fuel. అర్థమవుతుందా? ఒక ఫ్యూయల్ని బర్న్ చేయాలి అంటే ఎన్ని కేజీల ఎంత గాలి కావాలి, ఎంత ఎయిర్ కావాలి తెలియాలంటే ఫస్ట్ ఆఫ్ ఆల్ అందులో ఉన్న కన్స్టిట్యూయెంట్స్ లైక్ కార్బన్, హైడ్రోజన్, సల్ఫర్. సో కార్బన్ బర్న్ చేయాలంటే ఎంతగా ఎయిర్ కావాలి, హైడ్రోజన్ బర్న్ చేయాలంటే ఎంత ఎయిర్ కావాలి, సల్ఫర్ని బర్న్ చేయాలంటే ఎంత ఎయిర్ కావాలో తెలిస్తే మనకు టోటల్ ఫ్యూయల్ బర్న్ చేయాలంటే ఎంత ఎయిర్ కావాలన్నది తెలుస్తుంది. సో ఇన్ ఆర్డర్ టు హ్యావ్ ద ఐడియా ఆఫ్ the quantity of air required for burning carbon, hydrogen, sulfur, etc., you should have the knowledge of the molecular weights. You should have the knowledge of molecular weights of these compounds. Molecular weights or molecular mass antaru. Molecular mass or sometimes atomic weight or mass. So, you should have the knowledge of atomic mass. So, we shall learn those values today. The first one is hydrogen. Or the first one is hydrogen. And this hydrogen is represented by the letter H. Chemically, it is represented by the letter H. And its atomic mass means it is mass of one atom is 1. Its atomic mass is 1. Molecular mass, generally 2 atoms of hydrogen forms 1 molecule, that means H2. So what is the molecular mass? There are 2 atoms each having 1 value, so it is 2. అంతేనే కదా? రైట్. సో ఇట్స్ మాలిక్యులర్ మాస్ ఇస్ 2. The molecular, this is the molecular symbol and this is the molecular mass. We shall write it separately. So molecular symbol is H2 and molecular mass is 2 for this. Similarly, if you take carbon, so the next one is carbon. So these are the constituents of fuels. So the carbon is represented by the letter C and its atomic mass is 12. Its atomic mass is 12 and carbon itself will act as molecule. So for molecule also it is represented by C. So it is also 12. For carbon, molecular mass is 12 and atomic mass is also 12. We cannot, you will not represent C2 like thing. So carbon is a molecule, that's all. And the next one is oxygen. It is represented by O. One atom is represented by O and one molecule is represented by O2. That means two molecules of oxygen forms one molecule. Sorry, two atoms of oxygen forms one molecule. So the atomic mass is 16 for it. So it is 32. Okay. Similarly, nitrogen. It is represented by N. Atomically, it is represented by N and it is having 14. Atomic mass is 14 and it is two atoms of nitrogen forms one molecule. So it is represented by N2. And what is this value? 28. Similarly, sulfur. Sulfur is S and its value is 32. For molecular sign also it is S only. So this is 32. You must remember all these values. So these are the reactants. These are the reactants of the combustion process. Similarly, by burning all these reactants, you will get the combustion products. So combustion products means, say for example, here the combustion product CO2. That means carbon. When reacting with the oxygen, it forms CO2. So CO2 ki enta vastund cheppandi ippudu. Deni molecular mass. It is a molecule. It is a molecule. So what is the molecular mass of this molecule? So carbon is having 12 and O2 is having 32. O aithe 16. O2 anam kabatti 32. So 44 is the molecular mass of CO2. Similarly, water. So that is symbol is H2O. So two hydrogens. That means 2 plus oxygen. One oxygen 16. So 18 is the molecular mass of this one. Similarly, carbon dioxide అయిపోయింది. Carbon monoxide. So carbon monoxide తీసుకున్నట్లయితే this is 12 and this is 16 only. So this is 28. And methane. Methane is CH4. So carbon 12 and hydrogen, each one there are 4 atoms. So 4 into 1. So that is 16. Ethane. So that is C2H4. Cheppandi, what is the value of this one? C2 means 12 into 2 plus H. 1 into 4. So this is 28. So this knowledge is required for calculating the minimum amount of air required for the combustion process. Okay? You have to by heart these values. You must by heart all these values. If you can by heart these values, you can easily get this value. You need not by heart these values. You need not by heart the products of combustion values. Simply you have to by heart the atomic masses or molecular masses of the reactants. That is sufficient. Okay? In the next class, we shall solve the problems. Right. Thank you.